well-known malware. So basically what we've got in the demo environment, we've basically got 4 virtual machines, okay? We're basically using VMware to leverage 4 virtual machines. We've basically got 3 antivirus vendors. We've got McAfee, Symantec, and Trend. And basically what we're going to do is we're going to detonate some malware. So basically I got a hold of some malware this morning, less than 24 hours old. And basically what we're going to do, we're going to detonate this malware just to see what happens with these various different antivirus vendors. We're also going to do exactly the same thing with Cylance, okay? We're going to detonate exactly the same malware through Cylance. What we're also going to do in this demo is we're going to detonate mutated files as well. So basically, we've taken those samples and we've altered them slightly so that the antivirus vendors will struggle to actually catch them. Really, this is what the attacker's doing, right? The attacker, all they're doing, they're not creating brand new malware, they're basically just mutating files that they've used before and have been successful before. So literally what we're going to do, we're going to fire some interesting pieces of malware, and again, big disclaimer, sometimes things pop up on the screen that you do not want to pop up on the screen, so if that happens, I apologize, because we are using, live malware. A lot of it is probably ransomware as well. So, let's kick off and start firing off some malware. And I'll talk through what's happening in the background, especially when we get to the Cylance part. Okay, so what we're going to do, we're going to kick off the original files, the less than 24-hour files. We're going to run them all through the antivirus vendors first. Okay, let's go. Run originals. I might end up doing it twice because that's not working. Okay, fantastic. Okay, fantastic. My demo's not working as well as it has done for all of this week. Okay, let's see. Let's try that again. Let's get a bit closer. There we go. Okay, we have some Wi-Fi issues. So basically what's happening is we're detonating almost 100 files through the antivirus signature engines, okay? So basically what's going to happen is all of these files are going to be loaded in a for loop, and we're going to see what actually happens in terms of effectiveness. We can already see at the top of the task manager, 3 files now loaded into memory, okay? And these are just relatively new files, okay? The signature engines have been updated. What's also going to happen across some of these antivirus vendors is that some of them are going to get cryptoed, okay? Some of them are just not up to date properly. They just don't have signatures available for this ransomware. So some of them are going to get cryptoed. What also happens sometimes is that some of these processes just start dying, the task manager gets closed, because really ransomware doesn't want to be detected easily. If you're analyzing ransomware, some of them have anti-evasion techniques and anti-analysis techniques as well. So let's see what's happening across. So basically we've got some sort of ransomware that's been detonated on Trend. Let's have a look on Symantec. So what Symantec does is it relies extremely heavily, it looks like we've just been infected by CryptoLocker on Symantec. And Symantec rely heavily on cloud lookups to make a decision, okay? So all well and good if you've got internet connection. If you haven't got an internet connection, you're in trouble. But what we can see here immediately is that Symantec believe they're encrypted by CryptoLocker down here in the taskbar. What's also interesting here is that actually there's been a batch file that's been attempted to be created called del.batch. So who knows what that could have done? Maybe it's a particularly malicious piece of malware that's looking to delete files. Okay? Let's see what's going on across the other AV vendors. So again, we've got a pop-up in terms of some type of ransomware that's taking place there. And again, sometimes you see things down here that possibly are not great in the demonstration. Let's see what's happening with Trend. Similar thing happening with Trend. Basically, they've been encrypted by a piece of ransomware. Okay, so all 3 virtual machines running traditional antivirus with up-to-date signatures have been infected. Okay, we've basically taken almost 100 files, we've detonated them through all of the various AV engines just to see what takes place. So we're going to do exactly the same with the Cylance virtual machine, okay? We're going to do exactly the same thing. We're going to load all of these samples through Cylance to see what happens. So let's see what happens. Basically, we're going to load the same for loop, and basically we're going to make a decision within 100 milliseconds whether these files are bad. What we're basically doing is we're preventing execution of things that we believe to be bad. Okay, and we're doing that within 100 milliseconds. So like I might have explained to you earlier in terms of machine learning, basically what we're doing is we're applying our local mathematical model and making a decision within 100 milliseconds whether something's good or bad. And if we believe it to be bad, we'll stop it from loading into memory, okay? Really, if something loads into memory, it's game over, right? That machine really is game over. You've got no confidence in that machine if something loads into memory. So basically all we're doing here was we're running through all of those files, and this is a blind Pepsi challenge. Okay, we might have done this same demo a couple of times today, but sometimes, the odd one does get through. Like I said, we're never perfect, but we're just trying to be a lot better than traditional signature-based technologies. Like I said to some of you earlier, we're effectively utilizing machine learning algorithms to basically make a decision on the future based on past data that we've learned from. So as we can see here, we're basically flipping through all of these files, making a decision, very low CPU and low memory impact as well, because basically we're just processing mathematics, okay? So, let's see what's happened with McAfee. That doesn't look too good either with McAfee. There is a piece of ransomware there that's loaded up on the screen. And actually, if you look on the desktop, we've got some interesting files that have been detonated and left on the desktop. So we've completely been cryptoed with McAfee. Let's see what's happening with Trend. It's still sat there chugging away. If you look down in the corner there, the CPU is absolutely pegged at 100%. This thing is completely toast. It's game over for Trend. That machine is definitely needs to be taken off the network as quickly as possible. Symantec, they're in a similar state. Let's click on this. Maybe we need to help it along a little bit. Let's click along on that. You can see down here, Symantec is actually trying to prevent an outbound communication from something that's detonated and loaded it into memory. Okay, so let's head back to Cylance. So Cylance has done its job. We've basically prevented execution of all of those files that detonated on the AV virtual machines. So we're going to revert all of these machines back to Snapshot. We're going to do the same thing again with the mutated files. So let's revert them all to Snapshot. The power of VMware and testing. Let's see. That's fine. Okay, so whilst we wait for that. So basically we're a software agent that basically communicates with an off-premise management system. So basically as a customer, you can basically deploy Cylance extremely easily. You don't need any on-premise management infrastructure. Basically when you become a Cylance customer, you basically get your own private management system held in the cloud. So it's extremely easy to deploy our agent and basically get installed and get up to date as fast as possible. In fact, an example I gave earlier, we had a customer last week, they rolled out up to 2,000 machines in one day. Oh, thank you very much, that's very kind of you. Rolled out 2,000 machines in one day. And of course, the beauty of having a cloud management platform, you have that ability to get up and running extremely quickly. Alright, so we're almost back to Snapshot. Let's wait until they settle down a second. Right, so we're going to do exactly the same thing. We might get slightly different results, but we're going to do exactly the same thing with all the various AV vendors first, and then do the same thing with Cylance. So let's run the mutations through the AV industry. So basically, very similar files that have been mutated. Basically, how you mutate a file is very, very easy. If I can do it, anyone can do it. There's a bunch of tools out there you can download for free. There's a tool called Mpress, for example, or UPX Packer that you could utilize to really just manipulate the file, make it look different and unique. So we can see here, we've got a couple of files immediately again loaded, into McAfee. You get some interesting descriptions sometimes popping up here in terms of the types of applications that are being loaded into memory. So basically here, we can see McAfee's going to do some cloud lookups as well. If you ever use McAfee, if you ever see something called Artemis that pops up into this box, basically what Artemis is McAfee is basically utilizing, if you like, the reputation of that file across other AV vendors. Artemis basically means, if I don't have a signature for it, if somebody else has a signature for it, then I'm going to call it bad. That's effectively what McAfee is doing. They're leveraging other people's information to make a decision. We don't leverage cloud lookups at all to make a decision. We have a local version of our mathematical model to basically make decisions on good and bad files. So let's see what's happening across Trend. We've got a really interesting kind of CAD application that's been loaded here, which is a bit bizarre. Sometimes you just never know what you're going to get with these samples, but some sort of interesting CAD application that could potentially be very malicious. Let's see what's happening down here as well. Looks like we've got some malicious URLs that McAfee is trying to prevent the outbound connections for. We have a look down here, see what's going on in the taskbar. If I just turn my back to you for 1 second. Again, we've had this similar kind of piece of ransomware that's kicked in and encrypted the machine. So as soon as something executes on this machine, you want to take it off your network as quickly as possible. It's game over for that machine. And basically what customers are doing is just running around reinstalling machines all day. They're just playing whack-a-mole. And that's really what we're trying to prevent. We basically want to add another friction layer into the network to help you prevent as much as possible. And that way you can really focus your effort on what you want to do in your day job. Hopefully you're not running around reinstalling machines because they're infected. So really, Cylance is all about execution control. It's all about blocking execution of bad things, okay? So, just before we do that, let's just take a quick look at that. No, that's not changed. So, let's go do exactly the same process. The Cylance, we're going to run the mutations now through the Cylance agent. Okay, run mutations. Fantastic. So, what should be happening again is basically these files that are brand new, never been seen before, they've been mutated this morning to make them look unique. Basically what we should be happening here is that we're going to prevent execution of files that have never been seen before. There should be no signatures available for these files. And that is really the power of the Cylance agent, being able to look at something, not from a signature perspective, but look at it from the millions of features that we extract from this sample set, and be able to effectively predict the future with brand new, never been seen before pieces of malware. So once we get through this, we should hopefully have blocked all files, and basically the system will go back and rest and just idle over to the CPU. So basically exactly the same process, exactly the same files that we ran through Cylance. Obviously nothing loaded into memory, there's no process that started. We blocked execution within 100 milliseconds of each of those files. So in a nutshell, that is the demonstration. Like I say to everybody, you have to do your own testing in your own environment to really prove the technology. So I really heavily encourage you to check out a proof of concept. We're more than happy to do a proof of concept with you. The proof is in the pudding. Please, put us to the test. Test us with your own samples as well. Don't just take our word for it. Use your own samples of malware to test.